Hello guys, welcome to Brilliant Qatar. Here we are discussing the second part of the chapter, hydrocarbon question discussion. In the part 1, already we discussed 30 questions and just wait for the remaining 30 questions in which all the questions from the hydrocarbon, most of the important and expected question from the hydrocarbon chapter, we are going to complete, okay? Just wait here and try to solve the question, again take the question and again to solve it and fight it, and we have to get full mark in this chapter. Okay, question number 31. Convert iodoethane to butane. When you're doing conversion questions, the reactions will be easier, my dear. Practice more conversion question. Convert iodoethane. What is iodoethane? CH3CH2IE, right? Iodoethane, we have to make it butane. We have to make it butane. So ethane is the starting, butane is the ending. That is doubling. Doubling means Woods reaction. Okay, what is Woods reaction? Treating sodium and dry ether. Treating sodium and dry ether. What we are doing in Woods reaction? We will take this one haloalkane. We'll take one more haloalkane. We'll take, no need to show this one during exam. Okay, only for understanding. One iodoethane, another iodoethane, and between we place two sodium. Sodium take iodine outside. Ethyl join with ethyl. We will get what? Butane. Right, butane. Byproduct not compulsory in conversion questions. Okay, next one. So butane, right? So the product is what? Butane we need to write. So CH3, CH2, CH2, CH3, right? Butane, okay. Question number 32. Sodium propanovate. What is sodium propanovate? CH3, CH2, COONA. Sodium salt of propanoic acid is called sodium propanovate to butane. Dear, sodium salt of an acid is here and you want overall butane, right? I'm using the process called Kolb's electrolysis. What is Kolb's electrolysis? Treat with the water, I'm not balancing, okay? Treat it with the water and pass electricity. Pass electricity. What is Kolb's reaction once again? What is Kolb's reaction? Sodium salt of an acid in water, when you pass electricity through that, I will tell you the product how to write. Very carefully, listen all, very carefully. I'll give a small hint how to write the product in Kolb's. Do you remember what you did in the decarboxylation? In decarboxylation, one carbon less alkane we are writing, correct? As that also actually starting from sodium salt of acid. But here sodium salt of acid, not doubling actually, right? 3 carbon here, butane mean 4 carbon, only 1 carbon increasing. So here, how to write the product in Kolb's is just double the alkyl group. That's it. In Kolb's reaction, just double the alkyl group. What is the alkyl group here? Ethyl, right? So it becomes butane. It becomes butane. So how to write the product in Kolb's, dear? Just double the alkyl group. Just double the alkyl group from the sodium salt. Okay, and byproducts, you know, NaOH, carbon dioxide, hydrogen gas. So Kolb's is very important, don't forget. Next one, hexane to benzene, one of the easiest and well-known reactions to you. Hexane, let me write hexane like this. CH3, CH2, 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 CH2 and CH3. Hexane, how you can make it benzene? You know, the reaction is called aromatization, correct all? Aromatization. Aromatization. You know what are the catalysts we are using there? Cr2O3 or V2O5 or MO2O3. The oxides of chromium, vanadium and molybdenum. At what temperature? 773 Kelvin and 10 to 20 atm pressure. What we get? Benzene. So how you convert hexane to benzene? Through aromatization. Don't forget the catalyst, temperature and pressure. 773 Kelvin, 10 to 20 atm pressure. Next one, how will you convert propene, okay? Propene to 2-bromopropane. What is 2-bromopropane? Yeah, 2-bromopropane. Can you say, my dear, what the reagent we need to add in? I am using HBr without peroxide, means Marconi-Kos rule. I'm using HBr. Add HBr without peroxide. Let me follow Marconi-Kos rule. What is Marconi-Kos rule? Negative part goes to carbon with less hydrogen, positive part to carbon with more hydrogen, product is ready. So if you want to convert propene to 2-bromopropane, apply Markovnikov's rule. Similarly, if you want to get Br at the end, means 1-bromopropane, what you have to use? Anti-Markovnikov rule. Check this question. Convert propene to 1-bromopropane. Propene to 1-bromopropane. Here we can choose which one? Anti-Markovnikov's rule. So let me add HBr in the presence of peroxide. So what happened? What is anti-Markovnikov's rule? Negative part goes to carbon with more hydrogen, positive part to less hydrogen, right? So normally if you want the Br at the center and the middle carbons, that is Markovnikov's rule. Mostly if you want at the end, means mostly it will be anti-Markovnikov. Next one. How will you convert butanol? What is butanol? CH3, CH2, 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 OH. How will you convert butanol to butene? Butanol to butene. Yes, what happened here? What happened here? Alcohol converted to alkene. That is dehydration. They actually take this OH from alpha, they took hydrogen from beta, and they did a double bond between alpha beta. That is dehydration. What is a dehydrating agent? Concentrated sulfuric acid and heat. Normally we are using 443 Kelvin. Heat is, you can mention like that. So alcohol on dehydration, we get alkene. Next one. But1ene 2. What we have? But1ene, okay? We have but1ene. How you make it but2ene? Dear, we want to just change the position of double bond from first carbon to second carbon. That's all right. I'll give you a method. Let me add HBr first without peroxide. Means Markovnikov's rule let me apply. What happens if you apply Markovnikov's rule? Negative here, positive here. I hope you get this one. CH3, CH2, CH2, Br and then CH3. Correct. Now what we are doing is, now let me do beta elimination. What is beta elimination? Treat with alcoholic KOH. What is beta elimination? Halogen go from alpha, hydrogen go from beta, we'll get a double bond between alpha beta. See, we got the double bond at the center. So if you want to convert but1ene to but2ene, do Markovnikov's rule first, then alcoholic beta elimination. Next one. How will you convert ethyne to ethanol? How will you convert ethyne to ethanol? Dear, a alkyne, okay, alkyne. If you want to convert into aldehyde or ketone, use oxymercuration. What is oxymercuration? Oxymercuration means addition of water in presence of HgSO4 and H2SO4 heat, mercuric sulfate and sulfuric acid. What do you mean by oxymercuration? What is the process called? Oxymercuration. Hope you remember we studied as this one, the tautomerism case and all. Yes, it's here. When an alkyne react with the water in presence of mercuric sulfate and sulfuric acid is called oxymercuration. What is the ions in H2, H2O, H plus and OH minus? It is a symmetrical alkyne, so you can add anywhere. Let me add H plus here, OH here. What do you get? CH2, double bond, CH and OH. This compound we call it as enol. Why it's called enol? Because it contains ene and ol. Ene mean double bond, ol mean alcohol. Yes, the carbon contain both ene and ol. It's called enol. If it enol form, it undergo tautomerism. What is this isomerism called? Tautomerism. What is tautomerism, my dear? Symbol. Can you see there is a alcoholic hydrogen? Which hydrogen? Alcohol. What is alcohol? OH. In which one hydrogen can you see? This hydrogen moved to this carbon. That's it. The alcoholic hydrogen moved to the nearest double bonded carbon. So this hydrogen reached here. So what is CH2 become? CH3. Double bond becomes single bond and CH double bond O. What is this compound? Ethanol. So if you want to convert a alkyne to aldehyde or ketone, do oxymercuration, tautomerism case. Next one. How will you convert phenol? What is phenol, my dear? Benzene with OH, right? How you convert phenol to benzene? Yes, we studied. Treat with what? Zinc dust. Reduction. Zinc. Zinc take this oxygen out. So what you get? ZNO. What is left? Benzene. If you want to convert phenol to benzene, just treat it with what? Zinc dust. Ready. Next one. How will you convert ethyne to nitrobenzene? My dear, let me do this process once again. I hope in the first part already we discussed this one. This is our ethyne molecule. When 3 ethyne molecule pass through red hot iron tube at 873 Kelvin, right? At 873 Kelvin, what happened? It undergoes cyclic polymerization. We will get benzene. But we don't want benzene. We need nitrobenzene. Do nitration. You know, benzene on nitration, we will get nitrobenzene. What is nitrating mixture? Concentrated HNO3 and concentrated H2SO4. We will be getting nitrobenzene. We will be getting nitrobenzene. Benzene on nitration, nitrobenzene. Next one. How will you convert benzene to toluene? Hope you studied Friedel-Crafts alkylation. Correct all? Friedel-Crafts. What is Friedel-Crafts alkylation? Add CH3Cl in presence of the catalyst anhydrous AlCl3. What is simply how we can answer this one? From benzene, one hydrogen and the Cl go out and the CH3 add into benzene. What is benzene with the CH3? We call toluene. What is the reaction called here? Friedel-Crafts alkylation. We added alkyl group on benzene. Similarly, we have Friedel-Crafts acylation also. This is the question. How will you convert benzene to acetophenone? We are doing CH3COCl, ethanoyl chloride with anhydrous AlCl3. What is happening? Same way, one hydrogen and the Cl out, COCH3, put it on benzene ring. Benzene with COCH3 is known as acetophenone. And the reaction is called Friedel-Crafts acylation. Next one. How will you convert benzene to benzophenone? My dear, benzene treated with benzoyl chloride. What is this compound is called? Benzoyl chloride. Okay. Benzene when treated with benzoyl chloride in presence of anhydrous AlCl3, what will happen? Same like our Friedel-Crafts acylation, H and Cl out, you will get benzene in which what? CO and one more benzene ring. This is called benzophenone. Benzophenone. You know, acetophenone mean benzene with the COCH3. Benzophenone mean 2 benzene ring, middle there is a ketone. Next one. How will you convert benzene to para-chloronitrobenzene? If you want to get chlorine, you have to do chlorination. If you want to get nitro, you have to do nitration. But which will you do first? That's a question. We studied in class. What kind of product you want? Para, right? You know, chlorine is a ortho-para directing group. Nitro is a meta-directing group. My dear, halogens are weak ortho-para directing group. Nitro is a meta-directing group. What product you want? You want para. You want para, right? So the ortho-para directing group, add first, which is the ortho-para chlorination. So do chlorination first. What is chlorination? Add Cl2 in presence of anhydrous AlCl3. We will get chlorine. Halogens are ortho-para directing group. So the next group can come to ortho and para. So next to do nitration. What is nitration? Concentrated HNO3 and concentrated H2SO4. Nitro come to para position. Para position. So if you want a para product, the ortho-para directing group, add first. I'll show you one more example. Convert benzene to meta-nitrotoluene. Convert benzene to meta-nitrotoluene. Here, nitro is a meta-directing. Toluene. Toluene means CH3, right? It's an ortho-para directing. Which will you do first? You want a meta product, my dear. You want a meta product. So the meta directing group, add first. So do nitration first. So what is nitration? Concentrated HNO3 and concentrated H2SO4. What do you get? Nitrobenzene. Now nitro is a meta directing. It will direct the CH3 group to meta position. For that you have to do Friedel-Crafts alkylation. CH3Cl with anhydrous AlCl3. So CH3 where it goes? To meta position. So nitro here, CH3 here. Okay, these type of questions are 100% sure for exam. Next one. How will you convert propene to? How will you convert propene to propan 1,2 diol? What is that? Propan 1,2 diol. How we can do this one? Those who watch the part 1 video, they can answer. It is possible with Bayer's reagent. What is Bayer's reagent? H2O, O, and they will mention KMnO4. I told you what is the purpose of Bayer's reagent. Put 2 OH group on the double bonded carbon. Yes, that's what they did here. Get 2 OH group on the double bonded carbon. It is possible with Bayer's reagent. Next one. How will you convert benzene to benzene sulfonic acid? Sulfonation. We studied total 5 electrophilic substitution, right? Chlorination, nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. What is sulfonation means, dear? We are adding fuming sulfuric acid. In order to do sulfonation process, nitration mean HNO3 and H2SO4 together we add. This is only fuming H2SO4. You will get which group comes on benzene? Benzene with SO3H. This is known as benzene sulfonic acid. So benzene on sulfonation we get benzene sulfonic acid. Benzene with SO3H. Next one. How will you convert 1,2-dichloroethane to ethene? Do you remember this? This is a preparation of alkene from vicinal dihalide. Just treat with metal zinc. Zn take both of the Cl out, Zn Cl2 out, you will get a double bond here. So if you want to convert a vicinal dihalide to alkene, treated with what? Zinc. Next one. How will you convert propine? Okay, this is what propine to propan 2-on. What is propan? I told you, alkyne is given. Alkyne, if you want to convert into aldehyde or ketone, do oxymercuration. What is oxymercuration? Addition of water in presence of HgSO4 and H2SO4 and heat. You know, water contain 2 ion, H plus and OH minus. It follow Marconico's rule. Negative part goes to carbon with less hydrogen, positive part to more hydrogen. We get CH3, COH, double bond CH2. You will get the compound called enol. What is mean by enol, my dear? It contains en and ol together. It will undergo one isomerism. What is it called? Tautomerism. What do you mean by tautomerism? The alcoholic hydrogen shift to this carbon. The alcohol hydrogen shift to the nearest double bonded carbon. So what you get overall? CH3, CO, CH3. We will get propan 2-on. So alkyne, if you want to become aldehyde or ketone, do oxymercuration. Next one, 50, question number 50, okay. Sodium benzoate. What is sodium benzoate? Sodium salt of benzoic acid. Benzene with the COOH, what you call benzoic acid, right? This is called sodium salt of benzoic acid. How you can make it benzene? Under the preparation of benzene, we studied this is do decarboxylation. What is decarboxylation? NaOH and CaO and heat. Do a reaction with the soda lime. What do you get? The carbon dioxide part is gone. We will get benzene with the byproduct what? Na2CO3. Sodium benzoate, when you treat it with the soda lime, you will get benzene. They will give you, for exam, either they give you this part and they ask you to write the product. Next 51. Sodium propanovate. What is sodium propanovate? CH3CH2 COONA to ethane. So one carbon less, which means decarboxylation. What is decarboxylation? Treated with again soda lime. Here 3 carbon in your reactant, so a product will be 2 carbon alkene. That is what decarboxylation, and byproduct you know, sodium carbonate. 52, chloroethane. What is chloroethane to chloroethane to ethene? Chloroethane to what? Ethene. What is this reaction, my dear? Beta elimination treated with what? Alcoholic KOH. What is beta elimination? Halogen go from alpha, hydrogen go from beta, will get a double bond, right? Beta elimination. Next one, bromoethane. Bromoethane to butane. Doubling mean Woods reaction. Treated with what? Sodium and dry ether. You know, during Woods reaction, the alkyl group double. We'll get CH3, CH2, CH2, CH3. We'll get butane. Doubling if you want, prefer Woods reaction. Number 54, But-2-ine. What is But-2-ine? This is what But-2-ine. To cis-But-2-ene. You know, alkene, this is alkyne. Alkyne to alkene, right? No doubt, hydrogenation. What is hydrogenation? Addition of hydrogen. You know, one hydrogen get added here, one hydrogen get added here, triple bond become double bond. But how you get cis-alkene? We know if you want cis-alkene, we have to use Lindlar's catalyst. What is Lindlar's catalyst? Pelletized charcoal, right? Pelletized. It's called what? Lindlar's catalyst. If you want trans-alkene, we have to use a Birch one, right? Sodium in liquid ammonia. So we will add one hydrogen here, one hydrogen here. But it should be cis, right? So how you draw cis mean? Cis mean one H here, the CH3 here, one H here, the CH3 here. HH on same side. It's called cis-alkene. So if you want a cis-alkene from an alkyne, do Lindlar's catalyst, pelletized charcoal. 55. How will you convert But-2-ene to ethanol? Total 4 carbon in your reactant, only 2 carbon in product. Means the double bond cut. That is ozonolysis. How to do ozonolysis, my dear? First step, we will add ozone. How we add ozone? We cut the double bond. And add 1 oxygen above, 2 oxygen below, right? And this is called ozonide. And we will break it. We will break it with the help of zinc and water in this way. What is you have left side? CH3CHO. CH3CHO. Even right side also CH3CHO. What is CH3CHO is called? Ethanol, right? That's what we want. If you want to convert an alkene to less number aldehyde or ketone, we are using ozonolysis. Next one, benzene to, how will you convert benzene to gamaxane? What is gamaxane? BHC, right? Benzene hexachloride. When you treat it with the 3-chlorine in presence of UV light or sunlight at 500 Kelvin, what happened? Cl get added on all the carbon and double bond becomes single bond. You'll get Cl, 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 right? It's called BHC, benzene hexachloride, also called as what? Gamaxane. What is the formula? C6H6Cl6. All carbon actually having hydrogen, okay? C6H6Cl6. Then, how will you convert benzene to cyclohexane? Means we want to remove all the hydrogen. So add what? 3H2 in presence of nickel. Reduction. When you add 1H2, 1 double bond goes. If you add 3H2, all the 3 double bond goes, you will get cyclohexane. It's hydrogenation. Benzene on hydrogenation, we get cyclohexane. 58. How will you convert ethene to ethanol? Ethene to ethanol. If you want to convert an alkene to alcohol, just add water. Okay, add water in presence of an acid. You know, water contains 2 ion H plus and OH. It's symmetrical, so add anywhere. H plus here, OH here. What do you get? CH3, CH2, OH, ethanol. If you want to convert alkene to alcohol, add water. If you want to convert alcohol to alkene, remove water. Dehydration. 59. How will you convert ethane to 1-chloroethane? That is nothing but chlorination, right? Substitution reaction. Let me add chlorine in presence of light. Alkanes undergo substitution reaction. What is substitution? Remove H, add one, substitute one Cl. We'll get CH3, CH2, Cl. This is what? Substitution. So write the reactant side and product side. Then you check it what necessary requirement. I want to discuss one last question, my dear, and most important 3-mark question. Write the mechanism for electrophilic, and they will ask you write the mechanism for electrophilic substitution. Normally they are asking chlorination and nitration. Okay, listen carefully. Total 3 steps are there. Step number one is what is actually our reaction? Chlorination. Chlorination mean to benzene when you add chlorine in presence of anhydrous AlCl3, what you should get? Chlorobenzene. We have to show the mechanism of this reaction. Okay, under electrophilic substitution. What is step number 1? Step number 1 is formation of electrophile. Formation of electrophile. Step number 1 is formation of electrophile. Carefully all. Step number 1 is formation of electrophile. Ready? Chlorination, right? Chlorination means what you're adding? Cl2. Let me write Cl and Cl. Cl2 I am writing Cl. And reacting with what? AlCl3. Let me write AlCl3 is the catalyst. Dear student, carefully listen. This AlCl3, aluminium contain 3 bond, right? 3 bond means 6 electron. AlCl3 is having aluminium, the central atom contain only 6 electron, so it's electron deficient. Electron deficient, not completed octet, right? So they will take one of the Cl to aluminium. This Cl, one Cl, so this Cl is remaining as Cl plus, this Cl is remaining as Cl minus. The Cl minus goes to which one? Aluminium. So what you get overall? AlCl4 minus. AlCl3 is electron deficient compound. So it take one of the Cl as Cl minus. So AlCl3 plus the Cl, what you get? AlCl4 minus. What is the other one? Cl plus. This is our electrophile. What is electrophile charge, my dear? C plus plus. So this is our electrophile. So this is our first step, electrophile generated. But when you come to nitration part, careful. What is the reagent we are using in nitration? Concentrated HNO3 and concentrated H2SO4, right? Let me write HNO3 in this way. HNO3, I am writing HONO2. What is this? Nitric acid, okay? This is what our nitric acid, HNO3. I am writing sulfuric acid. Sulfuric acid, I am writing HOSO3H. This is our sulfuric acid, H2SO4. Carefully listen how the electrophile is generated. Dear, sulfuric acid is a more acidic than nitric acid. So sulfuric acid is ready to remove this hydrogen, correct? Sulfuric acid is more acidic, so it's ready to give H+. So by giving the lone pair, they will take the H+. From nitric acid, by giving the lone pair, they will take this H as what? H+. So this H plus reached here. Let me write HONO2 and new hydrogen reached here. This lone pair still there. Overall what happened here? This H plus moved to this oxygen. Okay. And this oxygen get a plus charge also. Why it's getting a plus charge? Because oxygen lose electron. Overall what happened here? Nitric acid and sulfuric acid. Sulfuric acid is more acidic. So it gives its hydrogen to this oxygen. That's all. And finally, dear, one more thing is happening. This bond break. This bond break and oxygen get electron. So what is this portion? H2O. That you leave it. What is the other part? NO2 plus. That's our electrophile. So during chlorination, who is the electrophile? Cl plus. During nitration, who is the electrophile form? NO2 plus. That is first step. Step 2 is common for both, okay? What is step 2? Carefully listen all. Step 2 is formation of carbocation. Formation of carbocation. Here also step 2 similar, okay? Same step. Okay, and where we are actually adding this electrophile on benzene ring, right? So let me bring benzene and to which who is the electrophile attacking? Cl plus. Carefully listen on. Listen carefully. When an attacking species comes to the double bond shifted to one of the carbon. Just for simple understanding. When an electrophile comes to a double bond, benzene, that one of the double bond shifted to one of the carbon. So what charge on this carbon? Plus, and what charge on this carbon? Minus. Because this carbon lose, this carbon gain. Now my question, where Cl plus will attack? One carbon got plus charge, one carbon got negative charge, right? Where Cl plus attack? On negative carbon. So let me write the product here. These two double bond, nothing happened. Okay, nothing happened. This chlorine reached here. Why chlorine goes to this carbon? Because it's negative, Cl is positive. And this already positive. Can you see there is a carbon with a positive charge here? That's what you call it as carbocation. So what is second step here? Formation of carbocation. And let me write one hydrogen here, okay? We need that hydrogen, just keep it there. Because this hydrogen is from where? It's already there in the carbon, okay? Now, what about step 2 here? This plus, who is the electrophile here? NO2 plus, right? NO2 plus. When this attacking species comes, what happened? Double bond shifted to one of the carbon. So what you get here? These two double bond, no change. NO2 reached here. This is plus charge and this hydrogen already there. So second step is over. We are moving to last step. In step number 3 is called deprotonation. What is it called? Deprotonation. Here also step 3, deprotonation. What do you mean by deprotonation? Removal of proton. What is proton? H plus. That's it. Let me take this compound once again. All of you carefully observe the last structure. I'm taking this Cl and H here and plus is there. Plus. To this one, do you remember this compound? It's not a byproduct. Okay, we need this one back. I'm taking this AlCl4 minus here. AlCl4 minus here. You know what happened, my dear? This shift, all of you try to understand. Can you see there is a hydrogen here? This hydrogen give its electron and becomes the double bond becomes which comes to the benzene ring. This bond electron shifted here, so we'll get the double bond back on benzene. So what is left there? Benzene with chlorine. So you got our product chlorobenzene or not? Yes. What are the byproduct? This hydrogen combined with one of the Cl, you will get HCl, and what is the remaining? AlCl3. Have you seen? We got our catalyst back. What is a catalyst? Without involving in the reaction, we can get it back after the reaction. So why it's called a deprotonation? Because it's a removal of H plus. This H is removing from the compound. Therefore, it's called deprotonation. Similarly, how you present in this side, my dear? Here we have this compound, right? NO2, HN plus charge. What will happen? This one react with the word and okay, I forget to write this one. Here actually what happened? This hydrogen goes to this oxygen, right? What is left there? Oh, what is left there? OSO3H minus. Like AlCl4 minus, we have OSO3H minus. Please bring it here. OSO3H minus. What will happen? This hydrogen, sorry, here no bond here. Here no bond inside. Okay, let me draw once again. NO2, HN, positive, right? What happened here? Deprotonation, right? What is deprotonation? Removal of this hydrogen. This hydrogen give these electrons to this bond. So we will get the bond back. We got benzene back. What on this one? NO2. So our product is ready. Nitrobenzene. What is the byproduct? Can you guess here? This H combined with this O minus and SO3H. What is that overall? H2SO4. We will get our H2SO4 back. So who is the catalyst actually there? H2SO4 is there. So total there are 3 steps in electrophilic substitution mechanism. First step is formation of electrophile. Second step is formation of carbocation. Third step is deprotonation. Mostly they ask you chlorination and nitration. Don't forget all, exactly like this one, present it. So chlorination mean who is the electrophile? Cl plus. So first to show how Cl plus is formed. Nitration mean NO2 plus. So show how NO2 plus is formed. Step number 3, add the electrophile on benzene ring. Add the electrophile on benzene ring. Finally, we need to get our benzene ring back. For that, hydrogen remove. We will get our catalyst back. These are the 60 reaction or 60 important. We discussed almost every reaction from this chapter, hydrocarbon. Practice well, all of you. Take each questions once again and solve again. Be master in hydrocarbon. All the best.